Consider f of x is x cubed minus 3x squared minus 24x plus 1. Find and classify all stationary points. So, we have f dashed x is equal to 3x squared minus 6x minus 24. We need f dashed x to be 0 for stationary points, so we have 3x squared minus 6x minus 24 is equal to 0, giving us x squared minus 2x minus 8 is equal to 0. And we can factorize that, and we get x minus 4, x plus 2. And so we would have x is negative 2 or 4. Substituting negative 2 back into f of x gives us the y coordinate, and we'll find that that is negative 2, 29. And substituting 4 into f of x gives us 4, negative 79. So we want to classify. Let's use the second derivative. So we're differentiating this again, giving us 6x take away 6. F double dashed of negative 2 is going to be negative 12 take 6, which is negative 18. The negative implies that we have a maximum. And f double dashed of 4 would be 24 take away 6 is 18. That's negative 18 there. And then the positive implies that we have a minimum. Find and classify all points of inflection. So we're looking at where the second derivative is 0. So we have 6x minus 6 is equal to 0. That will give me that x is equal to 1. Substituting 1 back into f of x gives me 1, negative 25. And since we know that we don't have a stationary point at x equals 1, this must be an oblique point of inflection. Find the intervals where the function is increasing and decreasing. So from what we know so far, we have a cubic and it's going to be shaped like this, and we've got a maximum up here, which happens at negative 2, 29. And then we've got 4, negative 79. We have our minimum. And so we can see it's increasing here and decreasing in between. So we think about increasing, that is when x is less than negative 2. So we're looking for where the gradient's positive, and where x is greater than 4. And to be a decreasing function, that is going to be in between those. So not less than or equal to, greater than negative 2, and less than 4. Find the intervals where the function is concave up or down. Well, again, from this, we know there's a point of inflection here at 1, negative 25. And we can see that the function is concave down around here up to that point of inflection. And remember, points of inflection are where concavity changes, and then it's going to be concave up around there. So it's going to be down for x less than 1 and up for x greater than 1. And then finally, we want to sketch the function. Now we could certainly, if we have the calculator available, get some more points to try to locate things exactly. But the things that we know so far are -2, 29, and this would be 30 here, so -2, 29 would be around there. That's going to be a maximum point. We know that we have an oblique point of inflection at 1, -25, which is about there. 4, -79 is our minimum point. And if we go back to the original function, the 1 that I've circled just here gives us the y-intercept. Remember, that's when x is 0. So that's going to be just above the origin, sort of there. And I used the calculator as well to get that the x-intercepts are -3.6. They're just sort of very close to this one here. And then at 6.6, which would be sort of around there. And then it's just a case of making the sketch. So we need to do the maximum, curl over, and it's going to get steeper down here. The steepest point will be the point of inflection. It starts to get shallower as it goes in towards the minimum turning point. And it's going to come back up there and just keep going. So something like that. We could mark on these points. So we've got the 1, -25. We've got the -2, 29. We've got the 4, -79. And if required, and we have the calculator available, we could find the intercepts and mark those on as well.